All righty. Well, thanks everyone. This has been good getting through all this. So now we can move on to the main presentation tonight, which is by our very own 84R, Mr. Mike, who runs our Thursday evening nets, as you may know. Is going to give us a update on volcanoes, which is a very fascinating topic that he has done some great research into. So,
and good evening, everyone. You all know me. Anyway, I'm going to talk to you about volcanoes. I'm very happy to do it, and I'm honored that you allow me to talk to you. It's kind of an off topic, but I'll return to amateur radio in the last slide. How about that? Anyway, I'm going to go ahead and fire things up. The topic tonight is Blast from the Past, VEI-7 eruptions in history. So please read the qualifiers there. I'm going to try to go slow enough so that you can read the captions and I won't have to read them for you. VEI-7, VEI stands for Volcano Explosivity Index. It's a scale that goes from 0 to 8, and it's exponential, very similar to the Richter scale for earthquakes. In fact, it might be synonymous with the Richter scale. Anyway, VEI factors involve the ones you see on screen. They range from 1 or even 0 to 8. And the one we're going to talk about tonight is the big one, VEI-7. And you can see from spheres that are displayed for you in 2D on screen, just how much bigger the VEI-7 volcano eruptions are than the VEI-6, such as Pinatubo in 91, and VEI-5, that would be St. Helens in 1980. So they're really, really big. Why VEI-7s for our talk tonight? Well, from my point of view, anything about volcanoes is interesting, especially the really big, the really big, gigantic eruptions. The VEI-7s are not the largest, but VEI-8s almost never happen, and we've already covered all the recent VEI-6s. You see them listed there. Another thing about VEI-7s is that they're extremely rare, only about 2 per millennium, if that. But on the other hand, they are terribly destructive over a wide area, and they have effects on the global climate. They bring on volcanic winter. Sounds terrible, and it is. These are the known VEI-7 eruptions in the Holocene epoch, which would be the last 12,000 years since the end of the last ice age. Anyway, so this is the list, and you can see that they're in a wide variety of countries. Most of them turn out to be on the Pacific Ring of Fire. And a good question that we'll address briefly right at the end is, were there any others? Another thing about VEI-7s is they all produce calderas, or they might come from calderas. What is a caldera? Well, we talked about this in a previous talk, but let's just go over it again. A very large volcanic eruption depletes the magma chamber that's way underground underneath it. And when that happens, the earth over the depleted magma chamber just falls in, caves in, collapses into that magma chamber. And the result on the surface is a great big gap in the earth. And over time, this caldera, that's what we call it, a caldera, fills up or may fill up with rainwater or seawater. And then over the thousands of years that follow, the volcano builds itself back up again, either rebuilding a volcanic mountain or just filling in the caldera. How do we know where VEI-7s were and when they were? Well, that's a big scientific problem. But in most cases, calderas from the Holocene epoch are still there. They remain evident on the surface. It's pretty obvious where they are. Crater Lake is a good example. Crater Lake in Oregon. We're going to talk about that later. We actually saw it already on the first slide. Some are so old that they're only visible from the air, or maybe even space. And Yellowstone is an example of one of those calderas that was discovered from space. Now that we know it's there, we can walk around or drive around in the caldera. It's so big. But we can find evidence that it is a caldera now that we know about it. And then finally, some calderas are underwater, under the sea. Submarine calderas, they're called. An example of that is Kikai. We're going to talk about Kikai later in the brief. Sometimes the where hasn't been identified. I showed you a list of all the VEI-7s, and there was an unknown in there. That's a case where an eruption location has not been identified. We may never know where it is. Now, when did it happen? Well, it's pretty easy to know when some happen. Like there were people around, there were civilized people, they recorded the dates. It's all a matter of record. In other cases, that history has to be reconstructed, and people spend a lot of time doing that. In other cases, there are geologists and volcanologists out with their little hammers going through the geologic record, the strata of the Earth. They're finding out when something erupted. And then finally, there's analysis of Arctic ice cores, Arctic and Antarctic too, that may show, as the one in the picture shows, a layer of volcanic ash that was laid on the ice long time ago. Well, here's the map showing where our VEI-7s took place. And you can see they scattered all over the Earth. But if this focused on the Pacific Ocean, most of them would be around the Pacific Rim. The only exception is Santorini, that happened in the Aegean Sea, and perhaps Changbaishan, which may not be a ring of fire volcano. But let's get to that. I'm going to go back in history. I'm going to talk about each one. I'm going to work backward in time, starting with the most recent. And be sure, we're all glad that we weren't there when these babies went off. First of all, let's talk about these VEI-7s that occurred in Indonesia. They were the most recent two, but let's first talk about Tambora, remembering that Indonesia is very rich in volcanoes, 147 active ones, and who knows how many extinct ones. And those active ones include these two, Tambora and Samalas, the last two, and also VEI-8 Toba, the largest volcanic eruption in the last 20 million years. Isn't Indonesia lucky? And by the way, Toba is still active too. All right. The first one on our list, going back in time, is Tambora. You probably remember this picture from my most recent talk on volcanoes. This one was, this shows a painting that it may have been exactly, or it may have been sort of what looked like the mountain looked like. It was a tall conical volcano, one of the tallest mountains in all of Indonesia before the eruption in 1815. Well, when it erupted, it produced the prototypical pyroclastic flows that were prodigious in volume and spread out in all directions, covered most of the northwest tip of Sumbawa, and even flowed over onto the neighboring island of Lombok. And we'll talk about Lombok next. The volcanic ash spread and went up into the stratosphere and shared the effects of Tambora with all the world. And I'll show that in just a minute. And for the people that were there on Sumbawa, it meant death, starvation for those who survived, because all of their crops and all of their livestock were destroyed. And this is a typical pattern for VEI-7s. Just keep it in mind when I show you the next few volcanoes. This is what Tambora looks like today. It's a vast hole in the earth. Looks like a moon crater to me, but you notice that the ground around it is all still quite desolate. That's all pyroclastic material from the eruption. This crater is wide, and if you go on the internet, you can find YouTubes that show hikers that go up to the rim of the volcano and look down. Those are especially good to watch. I recommend them highly. You'll enjoy them. Anyway, the caldera is relatively small for our VEI-7 eruptions, as I'll show you during the talk. In the same year that Tambora took place, also took place the Battle of Waterloo. This is a really great and decisive battle in history because it signaled the end of Napoleon, the end of the Napoleonic era. It was really important socially and economically. But you've all studied history, and so the year 1815 should be familiar to you. But 1815 was also the year of Tambora and signaled the start of the volcanic winter that occurred after Tambora. And the year was 1816, well known in history as the year without a summer. The weathers around, the temperatures around the world were dropped several degrees, and the result was that in some places in the world, particularly here in North America and also Europe, and especially in China, there was unusual cold. Crops failed, and snow even fell here in Virginia in July. The next one that we had is Samalas. I was telling you about that. That was on the nearby island of Lombok, and you can look at those two volcanoes, those two calderas, and see that they're almost within sight of each other. Interesting. Well, they were apart by several hundred years. Lombok was a kingdom, an independent kingdom in those days, and it was pretty well settled. This volcano occurred in the same way that Tambora did. There was a large volcanic mountain, very high, and when it erupted, it collapsed. Pyroclastic flows resulted and flowed over the island, devastated everything, and produced the usual widespread ashfall and tsunamis. So this was it was probably a larger eruption than Tambora, and it was equally destructive. This is what the caldera for Samalas looks like. It is and you'll recognize this pattern as we go through the talk, that this is what these calderas look like. This one has filled up with water and became a lake. And in the middle of the lake came a lava cone that's built up over the years with eruption after eruption, and shows that Samalas is still a very active volcano. This view is from the neighboring volcano, Rinjani, which is sort of a twin volcano. And you may read about this in literature as the Rinjani volcano rather than Samalas. Samalas is the ancient name for it from the old kingdom of Lombok. And there is actually a historical record that talks about this volcano. The Babad Lombok is a medieval document that was written on dried palm leaves in an old Javanese language, and records the volcano as a terrible event before the year 1300. And the little box toward the bottom left records some very poignant words translated from the Babad Lombok, very poignant and sad. Samalas also had a devastating impact on the environment. I wrote on here that it may have released the largest amount of sulfur into the atmosphere in the last 7,000 years. That's a long time and a lot of sulfur. And in any case, a lot of people believe that Samalas eruption and its impact on the environment helped bring on the little ice age of medieval times. This picture is intended to show the frozen over River Thames next to London back in those times. And those of you who have been to London and seen the Thames River, and can you imagine it looking like that? Next volcano working back in time is Changbaishan. That's referred to very often as the millennial eruption, since it took place very close in time to the millennium. This one, in similar fashion, collapsed a volcanic mountain, produced pyroclastic flows that flowed out over a wide area. And if you look at that map on screen, it does in fact kind of look like that area is still showing signs of devastation. Changbaishan is on the border with North Korea. And in North Korea, the volcano has a different name, Baekdu. This is the caldera for Changbaishan. Doesn't look all that different than Samalas. It has a beautiful lake called Heaven Lake that has filled it up. This volcano has long been thought to be dormant until the year 2002, when ominously it began to show signs of unrest. Unrest is a term that's used in volcanoes to describe those that are not entirely asleep, showing signs of possible eruptions in future. Well, since 2006, Changbaishan has been sound asleep, but the unrest could be a sign of future activity. Now, here's a potential problem for Changbaishan, and I posed it as a question for the powwow net sometime. Would a powerful underground nuclear explosion at the North Korean test facility, only 80 miles away, disturb the Changbaishan magma chamber enough to trigger an eruption? Well, you can imagine the Chinese are very concerned about this. So for myself, I don't think it would happen, even if the North Koreans set off the largest explosion they could ever manage. But could be wrong. I would hate to be wrong. Anyway, this is the next volcano going back in time. We hop from Asia to New Zealand, and New Zealand's North Island, which is very volcanic. In the middle of the North Island, you see Taupo caldera. It has been the scene of some extremely large eruptions. The Hatipi eruption in 233 of the Christian era may be the largest eruption of the last 5,000 years. But it's the scene of plenty of other big ones too, including a VEI-8, 26,500 years ago, and some VEI-8s and 7s before all that. This is a place that is a stomping ground of really big eruptions. This one was a good one to have missed. Take note of the shaded area inside the dashed line. That area was completely covered by pyroclastic flows. Everything in it would have been killed or destroyed. The contour lines that go off to the east show the ashfall, the depths of ashfall, and the one on the outer line is 10 centimeters, which I measured out at about 4 inches. Imagine having 4 inches of volcanic ash piled on top of your house. And then the next thing that happens is a rainstorm comes along and makes it much heavier. Well, this is what happened at the ancient city of Pompeii when the Italian volcano Vesuvius went off and covered the whole city with ash. Roofs fell in, and the whole city was lost to history by being buried with ash, and then pyroclastic flows. This is the Lake Taupo caldera, or as most people in New Zealand call it, Lake Taupo. It's immensely large. It's the largest of the calderas that I'll talk about. It's really big. It has great fishing. The Taupo volcano that's under it is dormant, sleeping. But you can imagine that nervous New Zealand scientists keep careful track of everything that happens in the Taupo caldera. Now let's hop even further back in time, before the Christian era, to 1610 BC. And we're now in the Aegean Sea, looking at a tiny island group that in the day was referred to as Terra. Nowadays, it's called Santorini. It's the Santorini resort and caldera. Santorini gave us one of the largest volcanic eruptions of the human experience. You'll notice that just to the west is Greece, which in those days was the Mycenaean Empire, and in later times was Sparta, and to the east, Anatolia, which in the days of Terra was the Hittite Empire. And then to the south, there was the Minoan Empire with its capital at Knossos. Those of you who have read a lot about Mycenaean age Greece are familiar with these places. Well, Santorini today looks like this. It's a group of small islands around a central caldera. It's a submarine caldera, the first we're going to talk about. But the volcano is growing back. And you can see in the middle of this caldera a new island. It's new over the last 300 years. It's grown back. And in the middle is a crater. Well, when Santorini erupts, that's where the eruption is. The last eruption here was in 1950. Still quite an active volcano. Santorini itself is, as I said, a resort. There, the ancient civilization that lived there has been excavated extensively. They found all kinds of art and artifacts. They found the ruins of buildings. In fact, Santorini is is associated with the legend of the lost continent of Atlantis. I don't hold too much with that, but a lot of tourists like to go there, particularly on cruise ships. It's as you can imagine, Greek scientists keep careful tabs on Santorini because there's no doubt that it's going to erupt really big again someday. So my advice is to go see Santorini on YouTube and take a cruise, take your pleasure cruise somewhere else. So the next volcano, VEI-7, stepping back in history all the way to 2300 in the before Christian era, we see one in northern Argentina. This one's near the border of Chile and Bolivia. It's way up high, over 15,000 feet. The volcano may still be active. The Argentine Volcano Authority thinks it is, but there's nothing been happening up there for thousands of years. So maybe not. This is what the terrain looks like. And one word of describing it is desolate. Another way that I like to think of it is it looks like the pictures I've seen of the surface of Mars. It's just desolate. And it's also pockmarked not only with the caldera for Cerro Blanco, but also with evidence of other very large eruptions on this place in the high Andes Mountains. This is a chart, an interesting one, that shows Cerro Blanco in comparison with Santorini, larger even than Santorini, and much larger than Tambora. And also on the far right, you see the Taupo supervolcano, and you can see how vastly greater its eruption volume was than even the largest VEI-7s. I also have to say that Cerro Blanco is not a unique volcano in the central Andes. There are lots of them up there. Most of them haven't been explored well, and some of them haven't even been named. There are really a lot of them, and a lot of them are active, and they could erupt really big at some time in future. Now let's hop from South America to Japan, which I have called the land of calamities. And why would I do that? Well, I made a list, starting with the self-generated calamity, and the worst of all, starting a war against the United States. Well, there are plenty of other natural calamities. All the kinds that happen in Japan: typhoons, earthquakes, tsunamis, and volcanoes. There are over 100 volcanoes in the territory that Japan claims. And there are several really big VEI-7 calderas, most of them on or near the southern main island of Kyushu. This is a close-up of Kyushu. It shows where Kikai is, the one that we're going to talk about, that is offshore. It's actually part of the Ryukyu Island group to the south of Japan, but still part of Japan. And the others are on the island of Kyushu itself. The largest one is Aso, where there have been 4 consecutive VEI-7 eruptions, all of them bigger than the last. The last one was 90,000 years ago, and it looks to me like it could happen again anytime. So that's bad. But let's talk about Kikai. This is a picture of the underwater caldera, the submarine caldera that forms what's left of Kikai and what's happening again. You can see the middle is beginning to rise up again. Why would it do that? Well, think about a magma chamber that's filling up. The visible evidence of the Kikai volcano is the Iwadaki lava dome, which is where its frequent eruptions come from these days. Kikai is by no means sleeping. It is an active volcano that erupts frequently. Only its eruptions are in the VEI 2 to 3 range. I call Kikai the destroyer for a good reason. When Kikai erupted back in the day, with its VEI 7 eruption, it sent ash falling all over the islands of Japan and far beyond. It sent pyroclastic flows and tsunamis across the 100-kilometer distance between Kikai and the mainland of Kyushu. By the way, pyroclastic flows flow more efficiently over water than they do over land. The dashed line across the landmass of Kyushu shows the zone where the pyroclastic flows completely covered the land and killed everything in there, wiping out early human settlements on the southern end of Kyushu. This land was not repopulated for hundreds of years afterward. And here's a good view of why that might have been. This is a pyroclastic desert. That's not a term I found on the internet. It's one I invented, but it seems apt. This is from the VEI 6 eruption of Nova Erupta in Alaska in 1912. This pyroclastic desert is 30 meters thick. This pyroclastic flow covered what was a forested valley and is now just something called the Valley of 10,000 Smokes. So you can imagine that a big eruption that would cover part of Kyushu would look something like this. Well, will there be a future Kikai eruption? Well, I don't see how they can discount it. I think it's likely there will be. Certainly, the volcano remains very active, and this shows a map taken a Google Maps view of the Kagoshima prefecture, which is that part of Kyushu that was buried in pyroclastic material when the Kikai volcano erupted. And so you can see that there would be a lot of civilization, a lot of houses, a lot of city that would be in grave danger. Now let's hop to the all-American VEI 7 volcano, our very own Mazama, that's in our great state of Oregon. This Mazama was a mountain much like, I think, Mount Hood and Mount St. Helens, Mount Rainier. Only in 5700 BC, it exploded, and the mountain caved in and formed a caldera that's now called Crater Lake. This is a map that shows the distance of Crater Lake, the caldera for Mount Mazama, from the Oregon Pacific coastline. The eruption caused ash to spread all over the Pacific Northwest and as far as Canada, destroyed everything, every living thing for miles around, and then hopefully fell dormant. The volcano, as near as I can tell, is dormant. However, the American U.S. Geological Survey considers Mazama, or Crater Lake, a dangerous volcano nonetheless. This is what it looks like today from the air. This is the caldera for the Mazama eruption. Mazama, by the way, was the name of a Portland, Oregon hiking club, and it gave the name of the club to the mountain that was there before that none of us have ever seen. That was in about 1895, and the club had a hand in getting the Crater Lake designated a national park in 1902. I've never been there, by the way. I hope some of you have. For the last volcano we're going to talk about, I offer you Mother Russia. This is a far and remote bit of it, the Kamchatka Peninsula, and way down at the end of that is a vast lake. This is Kurile Lake, and it is the caldera for a VEI-7 eruption in 6440 BC. It's about the same as Tambora for eruptive volume, not as great as some of the others that we've just talked about. The pyroclastic material that flowed out of the eruption went across east and west and reached both coasts. That's pretty good looking at this inset map. There's a little island out in the middle of the lake, an ancient lava dome, but this lake has been dormant since the eruption. Today it's a freshwater filled lake, really big one, and it's a popular, well, I shouldn't say popular, but a famous habitat for Russian brown bears. If you go online and you find YouTube videos of this place, you can see the bears playing in rivers that flow into the lake, and they give hardly a glance to the humans around, which I noted carry rifles just in case the bears do take an interest. You can watch these YouTube videos. You could even sign up for a tour to go to this place, but you'd have to ride in a rickety old Russian military helicopter to get there. And then you'd have to ride in a rickety old Russian military truck to go someplace. And when you got there, you could go on hikes that would be really great if you're a hiker. And then at night, you'd gather around a campfire and you'd sing songs in Russian and drink vodka. All right, we've gone all the way through the 9 VEI-7 eruptions in the Holocene epoch, the last 12,000 years. And I've marked each one of those on a chart here. The red bars signify the eruptions, and there you can tell by the scale on top about when those were. 9 of them, but there are big gaps shown by the blue arrows. What happened in those times? Were there any VEI-7 eruptions during those times? Well, probably, but we don't know where they are. These are the only 9 that are known for sure. But I showed on the list when I started talking about one that was unknown in about 1465 of the Christian era. And I show that by a little green dashed line way up toward the right end of the chart. And I've shown a dashed line back in the between 7,000 and 8,000 BC for another one. And let me just talk about those real briefly. And I must say that it's also possible that some of the very large VEI-6 calderas that exist in the world might have been VEI-7s. I could think of a couple, but we'll go on. The one in 1465 was nailed on the date for the date. Absolutely, there's no ambiguity about the date. It was in 1465, and we know this because the the effects on the world climate began to happen in exactly a time with a royal wedding in Naples, Italy in October 65, when Alfonso and Maria got together. This is, these extreme events were noted in records being kept by the day, so we know when it was. That day was also followed by months of bad weather in Europe. So a volcanic winter had set in. What caused it? Well, we don't know. The cause of that volcanic winter is still unknown. It's evidence that it may have been that it was a massive eruption, possibly a VEI-7. And the first most likely culprit that was pounced on was a submarine volcano, Kukai, in the Vanuatu Islands of the South Pacific. It was suspected, but is now discounted. It was proven that whatever happened at Kukai happened maybe 15 years before the events in Naples, Italy, with the royal wedding. So it wasn't it. And Kukai has been discounted in other ways too. So it wasn't Kukai. But what was it? Was it another submarine eruption somewhere? We may never know. Now let's go to the other end of the time scale, back in the year approximately 7420 before Christian era. On a tiny island, Unimak, in the in the Aleutian Islands of Alaska, there is a vast caldera. It's called the Fisher caldera. It's larger than any of the others we've talked about, except for Taupo and Kikai. This is scored these days as a VEI-6 eruption, but it's easy to argue that it might have been a 7, purely on the size of the vast caldera that's left as a reminder on the Earth's surface. There are other possibilities for really big ones, really big calderas, really big eruptions, all in the Aleutians and in Kamchatka, for that matter, and other places. Now, when is the next eruption going to happen? Well, we don't know, of course, but we do know that there's never been a VEI-7 eruption in a modern developed country, such as the United States. What also we don't know is the ability of a modern society to withstand a VEI-7 and all its very bad effects. We do have some examples that we can point to. The best one is probably the international response to the Pinatubo eruption of VEI-6 in the Philippines in 1991. I showed you pictures of that in my previous talks. We could also point to the international responses to the disastrous tsunamis in northwest Sumatra and the north coast of Japan within the last 20 years. But in those cases, the destructive agent was the ocean, and it came ashore, and then it went back to where it came from, leaving nothing on land except destruction. Well, if it's pyroclastic flows we're talking about, as in Pinatubo, as in Nova Rupta, they come and they don't leave. They stay there forever. Well, if one is certain to happen, what's uncertain is where it would be. Well, we're talking about eruptions in modern developed countries. Here are my guesses: Italy, Indonesia, Japan. Pretty easy, actually. No brainers, in fact, if you've studied these things. Well, now, what about the probability of a VEI-7 eruption in the near term? turns out last June, the cold-hearted bankers at Deutsche Bank in Germany thought about this and predicted the probability of catastrophic events within the next 10 years. And notice we're almost all the way through the first year of those 10. They figured that there was a 2% chance of a flu pandemic that would kill over 2 million people. Well, you remember my flu pandemic talk, so that's pretty credible to me. Then there's a 0.15 chance of a VEI-7 volcano eruption taking place with all the bad things that happen in the wake of that we've just talked about. Well, I see a potentially huge role for amateur radio and its emergency communications capabilities. So there's your connection to amateur radio for my talk. I think it's actually pretty important. Hopefully none of us will ever experience a VEI-7 eruption. As we've seen, the effects would be both local, actually kind of a wide area local, and worldwide. They would include ash falls, lahars, tsunamis, and especially pyroclastic flows. There would be vast casualties. There would be even more homeless people. It would be a terrible emergency. And then following that would be volcanic winter that would give us 2 or 3 bad years of hardship and famine around the world. So again, I can say with assurance that amateur radio emergency comms will have vital roles in a scenario like that. Well, thanks for attending, everybody. I hope it was entertaining and possibly interesting. And I do appreciate your giving me your attention and time to talk. 73, everyone.